Sound and light waves. In this video, we will look at a short introduction to sound and light waves. Then we'll solve some WASSCE past questions on sound waves and light waves. So let us begin with sound waves. Sound waves are longitudinal waves, and we saw that for longitudinal waves, the particles are displaced parallel to the wave propagation. So the same thing applies to the sound waves also. They are longitudinal waves, meaning the particles are displaced parallel to the wave travel or wave propagation. Then also, the frequency of sound waves is the number of oscillations in pressure per second. Then we have the wavelength is the distance between each successive region of high or low pressure. So the frequency of sound wave is the number of oscillations in pressure per second, whilst the wavelength is the distance between each successive region of high or low pressure. Now let's talk about the loudness. So loudness depends on the amplitude of sound waves. Loudness depends on amplitude of sound waves. So we should take note of this. Then also we need to take note of this fact that pitch is determined by the frequency of the sound wave. Pitch is determined by the frequency of sound wave. So pitch is to frequency. Then also quality is determined by overtone. So pitch is to frequency and quality is to overtone. Now let's talk about light waves. For light waves, they are transverse waves and they travel faster than sound waves. And we know that for transverse waves, the particles are displaced perpendicular to the direction of the wave propagation. So we know because light waves travel faster than sound waves, we are likely to see lightning before thunder. So that is something short on light waves, which are transverse waves, and how fast they travel than sound waves. We now take some few questions. These are first WASSCE May-June 2010. The amplitude of a sound wave determines its A. frequency, B. quality, C. loudness, D. pitch. So which of them is the correct choice? The amplitude of a sound wave determines its, which of the following is the correct answer? Is it frequency, quality, loudness, or pitch? So like we saw earlier, amplitude has to go with loudness. So amplitude goes with loudness. Therefore, the correct answer is option C. Amplitude goes with loudness. Now we have this one. A certain wave has a speed of 20 meters per second. If the frequency of the wave is 0.25 Hz, calculate the distance between successive crests of the wave. So that distance is the wavelength. The distance between the successive crests of the wave is simply the wavelength. And this is from WASSCE 2010, May, June. So let's see how we can calculate that. The distance between successive crests of the wave. So we need to recall the relationship between the wavelength, the frequency, and the speed, which is V is equal to frequency times width. V is equal to frequency times wavelength. V is speed, F is frequency, and lambda is the wavelength. So we can solve this relation for the wavelength by dividing both sides by the frequency. So let's do that. We have V. I'm rewriting it so that we can do the division clearly. So V is equal to F times lambda. V is equal to F times lambda. So now let's do the division. So remember, we are dividing both sides by F. So divided by F divided by F. So when we cancel out on both sides, then this will take care of this, and we are left with lambda on the right and V over F on the left hand side of the equation. So V over F is equal to lambda. Now we can also rewrite this as lambda equal V over F, and then we do our substitution. So lambda is equal to V over F. So the distance between successive crests of the wave can be found using this equation, lambda equal V over F. So we need to do our substitution now to get, we were given the speed to be 20 meters per second. 20 meters per second. So we have V to be equal to 20 meters per second. Then also we can also get another information about the frequency, which is 0.25 Hz. So the frequency is 0.25 Hz. So knowing all this, we can simplify, we can substitute into the formula to obtain lambda is equal to V, which is 20, V, which is 20, divided by the F, which is 0.25 Hz. So we will be doing some simplification here, how we should simplify 20 over 0.25. But before that, we need to rewrite the 0.25 as a fraction. So we can rewrite 20 over 0.25 as 20 we change the bar into a normal division sign to obtain 20 divided by 0.25. So this will give us lambda is equal to 20 divided by, 0.25 is the same as 25 over 100, which simplifies to 1 over 4. So the equation becomes lambda is equal to 20 divided by 1 over 4. So from basic simplification, we obtain our lambda to be equal to 20 times the reciprocal of 1 over 4, and that will be equal to 20 times 4. So 20 by 4 will be equal to, when you multiply 20 by 4, you get lambda to be equal to 80 meters. Lambda is equal to 80 meters. And the distance between successive crests of the wave is 80 meters. Now let's take another one. Two sound waves. Two sound waves have frequencies of 12 Hz and 10 Hz. Calculate their beats period. Calculate their beat period. So we can use the relation. This is a bit simple. We can use the relation F1, which is the frequency of the first wave, minus F2, and this is the frequency of the second wave, is equal to 1 over capital T. 1 divided by capital T. And the capital T is the beat period of the sound waves. So we just have to do the substitution for the first and the second frequencies, and then we solve for T. So we have from the question F1 is equal to 12, which is the frequency of the first sound wave, and F2 is equal to 10. F2 is equal to 10. And that's the frequency of the second sound. So they are all Hz, 10 Hz, and 12. So now let's do the substitution to find for the T, which we don't. So when we substitute, it will be very simple to solve. So we have 12 minus 10, which is the F2. Then for the F2 is equal to 1 over big T. 1. So 12 by 10 is simple. That 2 is equal to 1 over big T, which is the beat period. Now we can recall that 2 is the same as 2 divided by 1. Adaptation the cross multiply of T, but we can also use this approach with understanding that 2 is the same as 2 over 1. Then that equals 1. We can both sides. We can flip both sides to obtain 1 2 equal T. So this implies that T is equal to T over 1. Then half can flip 0.5. Therefore, the beat period of the sound is 0. The base period is 0.